Well, hello, this is Miss Billerbeck, and we're going to do 12.5 perimeters and areas of composite plane figures. Now, you may say, OMG, that's a lot, but let's look at what are plane figures. So a plane figure is like a triangle, a circle, or a rectangle. Okay, just something that's in a plane, kind of like this is a plane. Okay, so that's what plane figures are. Now, composite plane figures are when we have two different figures, one inside the other. So this one we have a rectangle with a triangle inside. This one we have a trapezoid with a circle inside. So once we add more than one plane figure, it's called a composite figure. All right, so that is how we interpret this new math jargon. Remember, math is a different language. All right, let's look at an example of a composite figure. So this particular one, we have a trapezoid. And this trapezoid here has a base of 4 and, a height of 4, because here is the right angle. So one of these is the base, okay? But this is parallel, so this side's parallel to that side. So our two bases are right here. So to find the area of this, we're going to take 1/2. And we're going to take the average of 6. Let me write this better as average, because I want you to get that in your head, that we're doing the average of the bases, and then you won't ever forget how to get the area of a trapezoid. So that's the average base times the height. So then we have 11/2. And then times 4, well, we can just take one of those 2's out here. So the area equals 22 units squared. So we have another figure. So if we break this A1, A2, we just found A1. Now let's find A2, the triangle. Okay, so we have 3 here, and this is 5. So A2, the area of the triangle, is 1/2 base times height. So A2 equals 1/2 times 15. So A2 equals 7.5 units squared. So A total equals A1 plus A2. So A total then is 22 units squared plus 7.5 units squared. So A total equals, and that'd be 29.5 units squared. So there you go. You did your first composite area. If they asked for perimeter, this one would be a little tricky, because we'd have to use the Pythagorean theorem to find this edge right here. And we don't know this. So this would be a difficult one to find perimeter. I think they are only asking for area right now. Thank goodness, huh? All right, let's look at example 2. All right, so this one, we could get really confused and say, oh, there's a trapezoid and a triangle and a semicircle. Ah! Okay, but really that's a parallelogram right there. So let's take the parallelogram out. And you don't have to do this separate drawing. I'm just doing it for you so you can actually see the two shapes. So we have a height here of the parallelogram is 15 and the side is 30. So the area of this, so if this is A2 and this one's A1, so A1 is base times height. So A1 is going to be this 30 times 15. So A1 ends up 430 units squared. Because 3 times 15 is 45, and then we have an extra 0 there. A2 is a semicircle. And this distance right here is 30. So that means the radius is 15. And this is 15. And this is 15. So our radius is 15. And the area for A2 is pi r squared. So we have A2 equals pi times 15 squared. So A2 ends up being 225 pi units squared. So A total equals A1 plus A2. So A total equals A1 was 430 units squared plus 225 pi units squared. Now if we used a calculator, we could combine these two. But if it says leave in terms of pi, then this is how you would leave it in terms of pi. Normally they say just leave in terms of pi, especially if they're not letting you use calculators, because that would be utterly cruel, don't you think? All right. Now let's look at the final example. All right, this one we have a trapezoid and another trapezoid. Okay, so we just want to find the area of this shaded region. So we're going to take one area and subtract the other area to find out this shaded region. All right, so A1 is going to be, and we have the bases are here. So here's the base, one base for A1, and one base for A2. And the height for A1 is 25. Okay, so this one's a little harder. So we're going to have to set this up and do some multiplication. So if we don't have a calculator, we can do a little multiplication right here. Let's do it the old-fashioned way. 5 times 2 is 10. Carry the 1. 5 times 3 is 15. Plus 1 is 6. Use 1 0 here. 2 times 2 is 4. 2 times 3 is 6. And we add them together. So we have 0, 10, 8. So this ends up 8 100 units squared. Okay, A2. Well, let's see. A2, we have one base is 30 and one base is 16 over 2, and the height for the second figure is 15. So that's 46 over 2 times 15. And that's going to be 23 times 15. So let's do a quick little bit of math here, since I'm running out of room there. So 23 times 15. So I'm getting the 23 because 46 divided by 2 is 23. So 5 times 3 is 15, carry the 1. 5 times 2 is 10 plus 1. Then we put a 0 here. 1 times 3 is 3. 1 times 2 is 2. And we add, and we get 5, 4, 3. So this is 345 units squared. Now, when we set up a total, this one's going to be different. We're not adding the areas. We're going to be subtracting the areas. So we're going to take A1 minus A2, because we just want this shaded region. So A total then is, we have 800 units squared minus 345 units squared. And let's use our little math area to do this math. So we have 800 and 345, and we're subtracting. So we're going to carry 1 over here. This is going to be a 9, and that's a 1. So 10 minus 5 is 5, 9 minus 4 is 5, and 7 minus 3 is 4. And we can quickly check. 5 plus 5 is 10. Carry 1. 1 plus 4 is 5. 5 plus 5 is 10. Carry 1. 4 plus 3 plus 1 is 8. So there we go. So A total equals 455 units squared. So we could take a very difficult problem and break it down into parts by breaking it up into composite shapes. And then we can find the areas of these shaded regions that are left behind. Isn't that cool? So now you know how to do this. Oh, we didn't do perimeters, did we? Well, let's look at a perimeter. I wonder why they did perimeter in this one. Well, actually, let's pretend. Okay, so we're going to pretend that if we were doing the perimeter of this, let's erase all this. Okay, so let's say if this is 24 and this is 25, the height, then this is probably a little longer. So I'm guessing, so mathematically this is not going to be correct, okay? I'm just approximating what the length of these sides are. So it looks like this side equals that side. We're going to assume that. So let's go with, this is about 27 and 27 over here. So if this one's 15 right here, I'm going to say this is probably, let's go with 18 here and 18 here. Then we can tell by subtracting 40 and 30 what these are. So there's a difference here of 10. If this is equal to that, 10 divided by 2 is 5. So this would be 5, and this would be 5. Well, now we can do the perimeter. So the perimeter, we just march around the perimeter. So we have 5 plus 18 plus 16 plus 18 plus 5 plus 27 plus 24 and then plus 27, and we're back to where we started at 5. So then we add this all up. 5 plus 18 is 23. 23 plus 16, that'd be 39. 39 plus 18, that'd be 49, 57. 57 plus 5 is 62. 62 plus 27. 62 plus 27 is 89. 89 plus 24 is 89, 113. Okay, 9, yes, 113. 113 plus 27 is 140. So we have 140 units. Now with perimeter, we're only doing units. Okay, so that would be how you get the perimeter. You just go and add up all the sides all the way around the cutout shape. All right, let's look at the perimeter of this one. So instead of doing area, we can do a perimeter. So we know this is 16, this is 30, and this has to be 16 because it's a parabola. We can find this out because it's half the circumference. So half the circumference because we're only going halfway around the circle, so we have half, and then we know what the diameter is 30. So it's going to be pi times diameter. The circumference is pi d, or circumference is 2 pi r. But we're given a diameter here of 30. So we have 30 times pi. So that's 15 pi. So now we just add it up. So we have 16 plus 30 plus 16, and then plus the circumference here that goes around here is 15 pi. So if we were to highlight what that circumference was, this is the circumference here, which is 15 pi. Okay, so we add up our like terms, and if it says leave in terms of pi, then we don't calculate this one. But we can, if we do calculate this, we can get a very precise perimeter. But if I'm not letting you use calculators, then you leave it in terms of pi. So this one, 16 plus 16 is 32. 32 plus 30 is 62 plus 15 pi, and perimeter is always in units, not units squared. All right, so now I can say that now you have learned how to get the perimeter and areas of composite figures. All right, be well. Bye.